Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by assembling the core prerequisites and taking action now. Install Python 3. 8. Set up a virtualenv and provision GPU instances. This gives performance headroom. Acquire Google Cloud Speech and Text-to-Speech API keys or decide on an open-source stack, because your voice pipeline needs reliable ASR and TTS. Prepare at least 1,000 labeled utterances and slot examples. This trains intent recognition. Once done, validate audio at 16 kHz and confirm API quotas so you won't stop mid-build. Now you build the core pipeline and tune behavior. Wire ASR into NLU so transcripts feed intent classification in real time. Streaming reduces latency, which matters for user experience. Fine-tune a pre-trained language model on your intent dataset and hold out 10% for validation. This shows how well your assistant generalizes. Implement dialogue management to map intents to actions, then connect TTS and device I/O. Make sure to include a robust wake word handler and attention state machine to avoid accidental activations. Finish by polishing, deploying, and preparing to fix issues quickly. Deploy to staging, run canary releases, and monitor latency and error rates so you can roll back if needed. Instrument analytics. Capture intent confusion matrices, session logs, and explicit user feedback to prioritize retraining. Automate a retrain pipeline so improvements roll out continuously. If misrecognition spikes, the key troubleshooting step is to expand ASR training data with 1,000 or more diverse, noisy samples and add augmentation. This usually reduces errors substantially.
Thanks for watching. Subscribe to keep your life in tune.